Okay, let's ignore, well, I guess we can have that stuff on there. Okay, I'm only going to go up to cubic though. I'm not going to go up to quartic. So what about this? We've got this table of data here, right? Ignore that stuff. I haven't fixed that part yet. So it gives us five values of time and the associated speed, right? So time is going to be, in this case, we're trying to find speed as a function of time here. Time is the input variable. Speed is the output variable for our function, right? Another way of thinking about that is the input variable is the independent variable and the output variable is the dependent variable. Somebody really quick articulate what those words mean. What's the difference between an independent variable and a dependent variable?
Independence on its own.
Okay, perfect, good. So independent is the one that stands on its own. Dependent variable are the values that you're calculating from the independent variable, right? It depends on it. Its value depends on the independent variable. So doesn't it make sense in this case that we want to come up with a model that's going to predict speed based on the time, okay? So here's what we can do on our calculators, and bust out your calculators. If you don't have one, I've got them here, okay? So if you don't have one, come up and grab one. You are, incidentally, going to want to probably have one of these, just because you're going to need one anyway. You're going to need one from all your math classes from here on out, high school and college. You will require to use these, as will virtually all of your science classes. So if you don't have one, get one. And by it, I mean the probably the most versatile, cheapest, most bang for your buck calculator you can get is the TI-84. You can get now, if you don't have one, you can get the TI-84 CE, which is the fancy new thin one that's got higher resolution. You get them at Walmart for $88. So it's a heck of a deal. They're out right now because I've been sending all my students there to get them. But you can just order one, site to store, and like in 2 days you'll have it. So it looks something like this. Here's your TI-84. Before we do anything though, I want to just kind of head off some future questions and difficulties at the past, and let's see what your operating system is on your TI-84, because you might want to update it. So go to second memory and then hit about. If you hit about, mine's going to look different because it's actually a computer emulator, but yours should say the system that you want to have is 2.55. Okay? If you don't have 2.55, you want to update that, and it's like getting a new calculator. It adds a whole bunch of really cool functionality to your calculator if you update it. So say it again. That's what yours says? Oh, what mine's going to say something different. Yours, because mine's not a calculator.
Mine says up there, it says 5.01.
It does?
0.0012.
Oh my gosh.
I don't know.
Oh, it does. Okay.
So, is mine 4.0?
Okay,
you
so
want it to
the
be 5.2?
that's interesting. So the CEs, I guess you do. Yeah. So the CEs are different. The CEs are not. They're not this. I'm used to seeing 2.55. Like on all the before this year, before the CEs were here. Most of you probably just have a regular TI-84, which is fine. It's the same stuff. Yours should say 2.55. If you've got an 84 CE, the rechargeable thin ones, I guess it's supposed to say 5.2. I think it's going to be fine if it's a little less than that, but you really are better off probably updating it. Updating it is really simple. If you want to update your system, all you do is you go to the TI. Actually, if you just Googled how to update the system on my TI-84, it'll tell you where to go and what to do. And then you just have to have that USB cable that you plug into your calculator and then into the computer. Charging cable. And if you don't have that stuff, we're going to be in the lab here very soon. And so the first day we're in the lab, I'll bring some of those and you can just update them there.
So mine's the silver edition, is 4.0.
Oh, that's weird.
Mine's 4.2.
You're all just,
Yeah, you are. So that one's probably the same as this though. I bet you're behind.
Okay.
I bet the new version is 5.2. I should look. This caught me off guard. I don't know what it's supposed to be.
If you want me to check right now.
Yeah, go ahead. So anyway, but you can just go on there and just look and see what is the most current operating system for your calculator, and then if there's a newer one, update it. Because you really do get lots of good functionality. When they update it, they add new stuff that's good.
You know that you can put Pokemon on?
No, I didn't know that. Did not know that.
I haven't yet. But
Okay.
I plan to.
So anyway, let's just assume for now, I'm going to go through this, and I'm recording this. So if you want to go back and look through this later to kind of, as sort of a how-to, if that's helpful to you, feel free. I'm going to do this though as though you've got 2.55. If you don't, if there's time at the end, come on up and I'll show you how to do the same stuff. But probably the better thing to do is just go get the 2.55 or whatever, the 5.2 or whatever is the newest one for your calculator, and then just do it this way. So, having said all that, all the fine print is out of the way now. Let's do this math problem. So to do this, we're going to go to the stat screen, because this is a statistical process that we're now engaged in. So we'll go stat, and then notice there are three menus on the stat screen. We get the edit menu, the calculate menu, and the test menu. We will use the first two menus and not the last menu probably all year. Okay, the edit menu, we want edit. So we'll just go ahead and hit enter, and then you're going to see what looks like a spreadsheet. Okay, what that means is list 1, list 2, list 3, list 4. So you're just going to make lists of values there that we're going to associate with the input and output variables, right? So the x variable, which in this case is actually t, right? T, we always put the independent variable or the input variable in L1. That's the default setting for the calculator. You can change it, but just don't bother. Just always be consistent and put the input variable in L1 and the output variable in L2. And so we'll do that. Now the easiest way to input these, not to just tell you how to do every little thing, you could certainly figure this out, but probably the most efficient way to do this is just to input column by column. So I would do, for example, 4, and then if I hit enter, it just moves down to the next value. So 4, enter, 10, enter, 11, enter, etc. And then just stop. Remember, those last two columns up there are just all jacked up in my columns, so forget those. Just go up through 19, okay? Then we want to go over to the next column.
You missed the 10 put 1.
Oh, I did? Whoops, thank you. So once we get down to the bottom, then if you hit the right arrow, it'll jump you up to the top of the next list, okay? So then we'll do the same thing. We got to make sure that these are like ordered pairs though, right? So the 23.2 goes with the 4, so it has to be horizontally opposite. And one way you can think about this that's kind of convenient is they are like ordered pairs then, aren't they? We're getting the x value and the y value, or in this case the t value and the v value, right? But just think of those as a list of ordered pairs, okay? Okay, once we get them all in there, now we've got all our data, what do we do with it? There's a couple of really important things we can do with this stuff. We can make a stat plot, so we can see a visual representation of the data, scatter plot, where we're going to get the x, on the x-axis and the y on the y-axis, or whatever we had, I can't remember, t and v. To do that, I'm going to show you a couple things here. Notice that there is a stat plot option on the top row behind F1. If I go second and then hit F1 or y equals, it takes me to the stat plot menu. So I can have up to 5 plots at the same time. We'll probably only ever have one, really. I mean, we maybe will have 2 at some point, but typically just one. If I hit enter, it opens up all of the options for stat plot 1. So what are they? Well, on, off. Do I want to see the stat plot or not? So if I hit on, good luck. If I hit on, it turns it on. The next row is the type of stat plot. So they're just icons. The one to the far left means scatter plot, and then we get line plot, and then we get histogram, and then we get the 2 kinds of box and whisker plots, etc., right? So which one are we going to use? Well, almost exclusively scatter plot. So that's the default because that's the one that most people use most of the time. So we haven't had to do anything yet, right, except turn it on. Go down to the next row and it says X list L1. Well, we already kind of talked about that, right? We said that L1 is always going to be the input variable, right? So on a graph, those would be the X values. And the Y list goes with L2. That's the output variables, right? So that's the default. That's what we assumed anyway. And then the kind of mark you can use various different marks, but I definitely recommend the one that's already chosen because you can actually see it for one thing. And then you can even change the color if you wanted to. Okay, so that's it, right? When we just hit enter, I guess we can actually just leave. We haven't done anything. So we can quit and it's all set up. Now I want you to notice what happens though. If we go to the Y equals menu, this is where we'd normally graph functions, right? And look at the graphs. Look what it did. It highlighted plot 1 because we turned it on. Okay? But we didn't really change anything, did we? So you don't have to. You can bypass everything I just showed you. If you're doing a scatter plot, a standard scatter plot, you don't even have to go to the stat plot screen. You can just turn on plot 1, plot 2, or plot 3 based on whichever one you're using. Okay? So how do you turn it on and off? Well, I just go up and highlight it and hit enter. Now I just turned it off. Turn it back on again. Well, okay, hit enter and it highlights it. So now it's on. So it's going to graph plot 1, which is based on L1 and L2 that I input into the stat screen. Okay, but how do I get it to match the window? If I just go up and hit graph, that's never a good idea because it's just a random graph. The size of the window we haven't controlled that at all, right? And if we look at our data up here, well, look, we have kind of a minimum X value is 4, maximum X value is 19. The Y values go from, and I'll just say X and Y, go from, maybe we could go from 0 up to 2163, maybe make them go up to 2170 or something. But we don't even have to do that. This gets so easy. The calculator does so much of this for us that all we have to do is just go to the zoom menu and choose option 9, which is zoom stat. So if we go zoom 9, look what it does. Somebody explain that. What did it just do? Yeah, good. It sized the window perfectly for us. It sized the window so our data was all represented. If you go to the window, you can see what it actually did. It chose the minimum value of X and the maximum value of X, so that's effectively the width of the screen, and then the minimum Y and the maximum Y, so sort of the height of the screen, so to speak. It did all that for us, and we can see our graph. Okay? So there it is. Now the next question is, what kind of a function is this? Right? We want to try to fit this to a mathematical model. Okay? So we can do some stuff. In the old days, you probably remember going back to Algebra 2 or maybe even Algebra 1. Do you remember the days when maybe you did some dorky stuff like you actually plotted those on a piece of graph paper and took out a ruler and, right? Yeah, I hate to tell you, but that's just worthless. There's no value to that at all. How come?
That's past.
It's passe. Yeah, it's old news. Why though? Why is that such a bad way of doing things? Oh, I heard lots of good answers. What do you think? How come? Not accurate. What else? Are you all going to be uniform?
No.
No, everybody's going to see it a little differently, right? Wouldn't it be amazing if we could take some data up here and we could all agree that instead of just all having pretty good curve fits, we could have the best one that we'd all agree on, that would match that data to the best, the most exactly, right? In a way that makes sense. Okay, there is. We can do this by regressional analysis. So now we'll go back to the stat screen and we're going to scoot over to the calc menu. Yeah.
The far left one.
Does it not look right? Do I have a data? Okay, so I must have something goofy in here.
You tried to redo the
Oh, but I didn't do it, did I? Yeah, okay, there we go. So that's supposed to be a 10, right? Okay. There, now let's try it. Is that better?
Yeah.
Okay, so let me do this then. I should probably go zoom 9 so it looks just like yours. That must look just like yours. Okay? All right, so now let's go stat, calc. And we'll do that a lot. Stat calc gets us to the list of all the options, and there's even more if I scroll down beyond that list. These are all the built-in ways that we can do regressional analysis. So we can fit these to a whole bunch of different types of curves. Well, let's do linear regression first, and we're going to choose the AX plus B form. So we'll do this a lot. Stat Calc 4 means that we're going to do linear regression, and we're going to figure out what the equation of the best fit line is. Okay, so if I go down to calculate, I want to show you something important here. Okay, look what it does. What does that mean? In fact, yeah, it's the equation, isn't it? Let me do that. Okay, that's the equation, right? The linear equation, the model is of the form y equals ax plus b instead of mx plus b. Big deal. But it's giving us the values of a, the slope, and b, start value, right? Everybody see that? Okay, so there's our linear model. Well, we probably want to know how good is the model, right? So to find out how good the model is, we're going to go back and look at, okay, we have to change something. So I should have some additional information on here, and you might, but I don't. So I have to turn on my stat diagnostics. So if it's not already on, go to mode and go down to where it says stat diagnostics to that row. You only have to do this once, and then your calculator will be set. And turn that to on. And I'm going to quit. So now if I go back and repeat the last calculation, there's a trick for that. You know, you just go second, enter, and then hit, so that pulls up the last thing I did. And if I hit enter, it repeats the calculation. I could also just go stat calc 4 and do it over. But look what I get at the bottom. I get some new information. Okay, the one that we're looking at is this. This is called the, what's it called? Correlation coefficient, and this is called the, I can't think of it at the moment, what R squared equals, technically the name. But I can tell you what it is. What it is it's essentially telling me how good a fit is it. And you can think of it like a percentage. It's not exactly a percentage, but it's a good rule of thumb. It kind of gives you an idea to get a feel for it. So if R squared is 0.902, that's about 90.3%. So that means that with about 90.3% accuracy, the data points were close to the line that they should have been for my best fit line. Does that make sense? Let's see what this looks like. Okay, so we can even do this. We can go back and let's repeat this calculation. We'll go stat calc 4 again, but we're going to add something this time. Instead of just going down and hitting calculate, we're going to go down and notice that it's just telling us stuff we already knew. The X list is L1, the Y list is L2, the frequency list is, I don't know what that is. If we go down to store regression equation, let's store this as Y1. So then it'll actually show up on our graph. How do we do that? Well, where do you think we should go if we want to store this as a Y variable? What button on my calculator do you think I should put to get a Y1 to put there? How about the variables button, right? So I can push the variables button and then scoot over to the Y variables menu and then choose function. And it gives me all these options of Y variables that I can input there. So I would just choose number 1, correct? Everybody see that? Okay, there is a shortcut for that too though. I'm going to show you the cool shortcut. So let me clear this and do it again. If you hit the alpha menu and then I go up to like F1 or F2 or F3 or F4, look what it'll do. This is, my screen is your screen, right? It gives me all these options at the bottom for alpha shortcuts. Alpha F1 gives me all the different fraction templates. Alpha F2, oops, I guess I have to hit that. Alpha F2 gives me all of these different commonly used functions. And alpha F4 gives me all of the Y variables right there. So the easiest way you can access the Y variables is just to hit alpha F4 and then type in 1 through 0. So we would just hit 1 or enter, and it pops that Y1 right there. Okay, questions so far? When I go down and hit calculate, everything looks the same as it did before. Same exact answer, right? But now look what happens if I go up to Y equals. Look what it did. It added to my Y1 row, it added that calculation out to like huge degrees of precision, right? That gave me that regression equation. Did yours do it?
Mine changed the numbers.
Did it put them backwards?
No, I don't know what it did.
Wait, can you go back to when you said y equals?
Yep, you betcha. So you want me to go back to here, stat, calc, 4, right? And so what you should have, does everybody's screen look like that? Everybody look like that? Okay, so then you want to go down to store regression equation, and you want to put a y1 there so we can store whatever it calculates as y1. So that's where we'll go alpha, F4, enter, because 1's already highlighted, or 1. You can just hit 1 also, and it'll put it there. I go down to calculate, and it's going to give me those numbers. Now, if you got different numbers than I did, the only way that can happen is if you have different data in your spreadsheet. Okay. So if I go up to y equals now, I can see that equation there. But even better than that, look what happens if I hit graph. Amazing. It gives me the best fit line right there. That is so cool. You don't appreciate how cool that is yet, but you will. That is really, really powerful. So there is our math model ready to be used. That's a predictive model that allows us to go find, like for example, if I want to know what does this model predict that the speed is going to be when the time is, let me do this so I got to see that table. When the time is 11, okay? So I can just go onto my model here to use that graph. I go second calc, and then I got a whole bunch of different things I can do with the graph. We just want value, so I'm going to hit enter or 1, and then I type in an x value. So if I put in 11 and hit enter, well, look what it does. It tells me a bunch of stuff. Let me make this bigger. So it tells me that the y function the function I'm using is y1, and it tells me that when x equals 11, the predicted value for y is 811.2. Okay? Pretty cool, right? You do that again? So to get that again, all we did was we went to, just go graph, and I go second calc value, and I type in the x value, and it's going to give me the y value, okay, for that function that I just built, for that math model. Now what happens if I hit the up arrow or the down arrow? It doesn't do anything, so I only have one function in there, okay? There's a shortcut for that also, a shortcut for everything. I can also just hit the trace button and then type in an x value. Actually, if I hit trace, look what it's on. It's on plot 1. I want to move down to my y function, so I hit the down arrow to scoot down from plot 1 to y1. And now I'm on trace. All I do, it doesn't give me any place to type x. I just type it. If I just type 11, it assumes I mean an x value, and if I hit enter, it tells me the y value. Pretty cool, right? And there's lots of other cool stuff it'll do too for a graph that we'll get to later. Okay, but that's not great, is it? I mean, it's cool, but does that line really fit that data extremely well? It doesn't, does it? It doesn't fit it awesome. Maybe there's a different kind of curve that'll fit it better. Let's explore our options. Well, we're only going to look at options today that are polynomial options. We're not going to look at things like logarithmic functions or power functions or exponentials. We're just going to look at polynomials. So let's go back to stat calc and look at, how about if we try a quadratic regression, right? Because a linear regression, remember that the biggest power of x is x to the 1. Quadratic is going to be x squared, right? Let's see how much better that is, if it's any better. So this time we're going to hit 5. And let's go down this time, and let's store this one as y2. Okay, so we'll go alpha, F4, 2. And then let's go down and hit calculate. Well, that's a lot better, isn't it? Look at R squared. R squared before was like 90%, now it's like 97.4%, right? It gave us this fancy quadratic model, and that worked better. And if we go to graph, we'll see that. There's our stat plot or scatter plot. We see the blue line, and now look how much better the red curve is. Okay, it's a lot better, isn't it? If we go back and we want to estimate what the value at 11 should be, well, let's take the shortcut and just go trace, and let's hit the down arrow to get to Y2, which is the red one. It's nice that it's color-coded. And then type in 11, and it gives me a much better approximation this time. Okay, that's probably better. All right. Well, we can keep going. We can keep going. Let's go do it. Let's add another layer to this. Let's go up to a cubic regression, where now we're going to use a bigger, fancier polynomial that has an x cubed as my leading term, right? So we go stat, calc, 6. Okay, and this time we'll store it, how about as y3? So we'll go alpha, f4, 3. Calculate. And it jumps it up even higher. Look, it jumps it up to 99.8% accuracy. Okay, that's good, right? That's a lot. That's significantly better. What did we get last time, like 97, right? Look how much better this looks when we go to graph. Linear, quadratic, cubic. The cubic fits really well, doesn't it? Right? Okay, so here's the part that's going to seem a little strange. If I do quartic, which is the next level up, watch what happens. Okay, if I do quartic, stat, calc, 7, I'll go ahead and store this as y4. And calculate. Okay, look what I get. I get r squared equals 1. It's a perfect fit. And the reason I kind of cheated, the reason it's a perfect fit is because I only have 5 data points. And not that this is really essential to know right now, but it's kind of interesting. How many points define a line? 2, right? 2 points perfectly defines a line. How many points define a parabola? You know? 3. Any 3 points, there's exactly one parabola that perfectly fits 3 points. How many points do you suppose define a cubic function? 4. How many points define a quartic? It would be 5. So there is exactly one quartic function, that one, that perfectly fits the data, right? Except, so do we want to use the quartic one? The answer is no. We don't want to because it's too complicated. We want to use the rule of thumb is we want to use the simplest regressional model that does the job. So as soon as we stop making significant jumps in accuracy, we don't need to go any further. If I look at the graph of this, did we really gain a lot? There's the linear, there's the quadratic, there's our cubic, which fit things pretty darn well, and there is our quartic, and look, the quartic got kind of bizarre actually. It turns too much, right? It starts to be too good. It gets too erratic. It starts to make real wild shifts. And so we don't want to use that one. Honestly, what we'd probably use on this one, I mean, it'd be either the cubic or even the quadratic does a pretty good job. It's not bad. I mean, it's pretty close to the cubic, right? But as a rule of thumb, I think we can say that as long as you're making jumps of like 1% or more, or even like a 1/10 of a percent or more, probably it's worth maybe jumping up to the next level of regression. Okay, does that make sense? But there's no need to go to quartic. Quartic makes it too weird, right? So your answers will always be on this assignment when I build this assignment. What I'm going to have you do is, there are going to be 2 parts to this. One of them is I'm going to have you give you some data. I want you just to go through the process of finding regressional models. So I'll have you find a linear model, I'll have you calculate a quadratic model, I'll have you calculate a cubic r squared, just so you get a little practice. But then the part that I'm more fired up about that I think is better is where I want you to make a prediction. So I'm going to give you an x value, and I want you to build the best choice of linear, quadratic, or cubic, and then input that value and get back a prediction. And that's going to be, so to get that one right, you would need to choose the right model and then plug in the value and get back the functional value, the value predicted by the function. So you actually have to think about it. You gotta maybe look at all three and decide, okay, is it worth going up to the next level or not? You know, did I get a pretty good answer? If I get a pretty good answer from linear regression, if I'm getting an answer that's like really close to 100%, why would I go any further, right? Does that make sense? If the data looks pretty linear, a line is a really simple model. We'd rather use a simple model than a complicated model. Get it? Kinda? It's a weird assignment. It's the only one we'll have like this all year. This is really, if anything, it's just kind of getting you used to the idea of regressional analysis. And it is stuff when we do some labs. You will do some regressional analysis to kind of maybe try to find a curve that matches the experimental data that you get. But it's like a different, it's really different. In the future, most of our assignments will be about using physics equations to make predictions about how high is a ball going to go when you throw it in the air or something. This is a little different. All right, have a shot at it. I'll take questions on it tomorrow and the next day.